how much would you guess if you import timestamp protobuf definition and just printed out how many lines of code?
In Go, if you imported?
Yes.
Oh, it can't be many, can it?
My guess would be about 30,000.
What?
I know that protobuf is ridiculously bloated, so that's my guess.
I thought it was all about being tiny little payloads. I was going to say 50. I feel like this is a good quiz.
27,000 lines of code.
Oh, wow.
Yeah.
Roger,
So
how did you get that so close? That's suspicious.
Order of magnitude. Yeah, no, Egon tipped me off. He didn't. I just know how big these things are.
This episode is brought to you by SourceGraph. SourceGraph is universal code search that lets you move fast, even in big code bases. Here's CTO and co-founder Byung Woo explaining how SourceGraph helps you to get into that ideal state of flow in coding.
The ideal state of software development is really being in that state of flow. It's that state where all the relevant context and information that you need to build whatever feature or bug that you're focused on building or fixing at the moment, that's all readily available. Now the question is, how do you get into that state where you don't know anything about the code necessarily that you're going to modify? That's where SourceGraph comes in. And so what you do with SourceGraph is you jump into SourceGraph. It provides a single portal into that universal code. You search for the string literal, the pattern, whatever it is you're looking for. You dive right into the specific part of code that you want to understand. And then you have all these code navigation capabilities, jump to definition, find references that work across repository boundaries, that work without having to clone the code to your local machine and set up and mess around with editor config and all that. Everything is just designed to be seamless and to aid in that task of code spelunking or source diving. And once you've acquired that understanding, then you can hop back in your editor, dive right back into that flow state of, hey, all the information I need is readily accessible. Let me just focus on writing the code that implements the feature or fixes the bug that I'm working on.
All right, learn more at sourcegraph.com and also check out their bi-monthly virtual series called DevTool Time, covering all things DevTools at sourcegraph.com/DevToolTime.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from all around the Go community. Check out our back catalog at gotime.fm. There you'll find the most popular episodes, our favorites, and a request form so you can let us know what you want to hear about on the pod. Special thanks to our partners at Fastly for shipping our shows super fast to wherever you listen. Check them out at fastly.com. And to our friends at fly.io. Host your app servers close to your users. No ops required. Learn more at fly.io. Okay, here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about avoiding bloat. Yes, indeed. I'm joined by Egon Elbre. Hello, Egon.
hello, Matt.
Welcome back to Go Time.
Yeah, it's nice to be back.
It's nice to have you back. And you build things at Store.j, right?
Yeah, storage.
Is that how it's pronounced?
Yes. That's the first question I always get.
Yep. It's GIF or GIF all over again. GIF or GIF. Yeah. Well, welcome. Yeah. We're also joined by Roger Peppe, hacker at qlang.org. Hello, Roger.
Hello, good evening.
Good evening. Welcome to Go Time. We shouldn't say good evening because we don't know when people listen to this podcast. One of the great things about Go Time is you listen to it on your own terms.
It's always the morning on the internet. Good morning.
It's always the morning somewhere on the internet. Well, people do terrible things in the morning then, in that case. Okay. Well, before we get going, Egon, I was interested. What have you been working on lately? Anything interesting?
So one of the recent things I finished was a project called Lensum, which allows you to browse source code and to compile the assembly side by side and see how code translates into assembly, essentially, and kind of do this interactively and kind of a nice way to visualize it when you're optimizing things.
Yeah, very cool. Because it's funny, like a lot of people, I think, stay at the code level and don't really dig into that. And it's quite apt for this conversation about avoiding bloat, like understanding what's this turning into.
Yeah, exactly.
Yeah. And Roger, Qlang, very exciting project. What's going on there?
I think it's an extremely exciting project. Yeah, so I've been involved with the language queue. I've been enthusiastic about it for a few years now, 2 or 3 years, since not so long after it came out, and recently had the opportunity to join the project. So I'm now working on it full time.
Yeah, amazing.
On this language, on this new language, sort of halfway between JSON and a normal language, I suppose, configuration language with some very, very interesting properties. It's a very cool project.
Yeah,
and hopefully should be useful for everyone now, but in the future. I think it has a big future.
So keep your eyes out. Well, we'll put a link to it in the show notes for anyone that wants to dig in more, and maybe we'll do a different episode on that at some point, Roger.
I think that's a great idea.
And Roger, you also play the fiddle, don't you?
Not relevant here, but yes, I do.
Very relevant, because I went to a party once and I thought I was having a stroke, but turns out there was a man playing a fiddle. That was you.
Oh, that was me, was it?
Yeah.
Oh, really? I was at the same party as you. Gosh, there we go then. I'll try not to do it again.
No, do it. I've never been. There's barely anyone ever playing a fiddle at any parties I go to. So
you just go to the wrong parties, evidently.
Apparently so. Okay, so let's get started then. When we talk about bloat, what do we mean? What is bloat?
So I like to kind of separate it to code bloat and binary bloat. So one is like your code is growing larger and larger, and the other is your binary, the final deployment thing, growing larger and larger.
Yeah. We'll bear those two things in mind then as we have this conversation, because I think they're both important to pay attention to in different places. With code bloat, like you can have like relatively small amounts of code, but if you have lots of imports, your binaries might end up being quite big, right?
Yeah. So I actually took up some statistics. I like to do some small quiz, right?
Oh.
So how much would you guess how many lines of code if you import the timestamp protobuf definition and just print it out how many lines of code would that cost? Like marshalling it, and like how many lines of code would it import?
In Go, if you imported?
Yes.
Oh, it can't be many, can it?
I reckon my guess would be about 30,000.
What?
I know that protobuf is ridiculously bloated, so that's my guess.
I thought it was all about being tiny little payloads. I was going to say 50. I feel like this is a good quiz.
27,000 lines of code.
Oh, wow.
Yeah.
Roger,
So
how did you get that so close? That's suspicious.
Order of magnitude. Yeah, no, Egon tipped me off. He didn't. I just know how big these things are.
Okay, the other common one is gRPC. Let's take it.
Yeah, well, I know that's a binary format, so that sounds small. A billion. I've learned my lesson.
gRPC is, well, that includes all of protobuf 2, right? So we're talking like
Yes.
maybe 120,000 lines of code.
Oh, it's going to be more than...
In the same ballpark, so 100,000.
Roger is suspiciously close to these. Do you count lines of code?
I have too much experience with large code bases.
Yeah, apparently. That tells you something, though, because it'd be very easy to just build what you imagine to be a very small project and just import one of those two technologies, and suddenly you're really talking serious numbers.
Yeah, compared to NetRPC, if you remember that package that not many people use, which is only about, 1,000 lines of code? A couple of thousand lines of code?
Yes, something like that.
Is that why people don't use it? It's not enough. People are like, I'm not buying it unless it's got loads of lines of code in it.
I mean, gRPC also has its entire copy of the HTTP, another copy of the HTTP2 stack and that kind of thing. So it seriously reinvents many wheels.
So would you have to import that to use it in a project, or is that just like the tool chain needs that?
No, the code that you import and the compiler has to parse through, essentially.
Well, you just don't notice because Go's build times they're so fast. Maybe we're spoiled by that a little bit.
Every single line of code adds 1 second to your build time. So,
well, that's what it used to do. That'd be good. You'd pay attention to code bloat if that were the case, wouldn't you?
I think it's all just got so ridiculous from my point of view. It started off back in the 80s where like like 16K was a huge amount, was a very large program. And now it's, on the many hundreds of megabytes. And like, well, does it matter? What does it really matter? I don't think it does. Like from my point of view, I think, unless you're really coming up against build times or against the binary sizes, what's important to me is the maintainability aspect of code bloat. Is about the bloat in the code that you maintain, not necessarily the bloat in the code that you're importing.
Yeah, right. So that's the other side of this then, is as projects grow and grow, you have to maintain that. Sometimes you can just leave code for ages and you never really have to touch it, but you still have the cost of maintaining that, don't you?
I consider every single line of code that you are the maintainer of it now.
Yeah. Every line of code.
Because maybe the maintainer goes on vacation and you have a critical bug that you need to fix.
So you've personally reviewed all those lines of gRPC code?
Yes.
Good work.
Luckily, I don't have to do it anymore.
You do that every time there's a new release? Or just read the diffs and then apply that in your brain?
No, we dropped actually gRPC for that maintaining reason.
Yeah. So that's interesting then. You sort of, when you import a package, I think it's because it's such an easy thing to do. I wonder how many people think I am kind of committing to also taking on the responsibility of looking after this entire other project as well. I don't know that many people have that mindset, do they?
I think it depends on the background where you come from.
Mm-hmm.
So if you start out by building websites and all that stuff, then probably you don't think about it. I used to work for an electronic medical records company. So there, every single dependency had to be thoroughly reviewed and whether it's suitable. And so,
yeah, for sort of regulatory reasons, I guess.
Yeah.
Yeah, I have to say that I don't personally review all our dependencies because I don't have the time. But if I take on a dependency, I look at the dependencies of the dependencies often. I'm almost more concerned about that. If something just depends on the standard library, I feel that I've got a handle on it. But if it's depending on other projects, then that's a bit more problematic. So in projects that I maintain, I try to keep the amount of dependencies, particularly when it's a library that some people are going to use, like the few I maintain, and I just try to keep the dependencies absolutely minimal if possible.
Yeah. So how do you do that? Do you have to manually go and look at all the projects?
I look at go.mod, actually, and I'm like, why have I got that dependency? Do I need that dependency? How can I strip it out? And I was doing that a while ago with, some fairly large code base. Why have we got this? And I came across, that was actually probably what ended me up with me and this call, actually, because I came across Egon's tool, Goda, which is a fantastic way to try and visualize, to see why you are using a particular dependency and how you might be able to hack it out.
What is that project, Egon?
So it was kind of for solving this problem of understanding your dependencies. So it stands for Code Dependency Analysis Toolkit. So I ended up kind of collecting these different tools, and then I eventually merged them into a single, a large bundle of them. It's at github.com/LOOV/GODA. So,
yeah.
And it has kind of features for, I try to explain it as you do calculations with package sets and dependencies. So you can kind of start removing things that you don't care about in the package list or graph. And then you can kind of drill deeper and figure out why is something being imported. There's also a subcommand Goda cut that displays packages that you might be able to easily remove because they don't have many incoming dependencies to them. So a bunch of tools.
Yeah, that sounds really good. I mean, as a rule, I kind of agree with you, Roger. I'll try and, if I'm going to import a package, I'll prefer ones that have just a few dependencies. And even sometimes I used to just copy bits of the code in with the license at the top, always, just to kind of avoid it. And often there's lots of tests, maybe something in the testing side that is, Testify has quite a lot of dependencies. Is that okay? Would you avoid Testify for that reason, or because it's in the test side? Are you all right?
Personally, yes, I would. I mean, but I'm biased, right? Because I maintain a package called trying to think what it is now. Quick Test.
Yes.
I'm one of the maintainers of that, which does not have many dependencies and is kind of a bit smaller. So I quite like that because Testify has lots of dependencies. But it's hard to avoid them because some dependencies are really useful, right? Like to print out diffs, for example, like the CMP package is great for that, but it's another dependency, right?
When I bring in dependencies, I actually do review most of the lines of the code. I also run our usual linter suite through the code base. And this means that if we import a new package, usually there are a few fixes that we contribute upstream already. Like maybe there's a data race, maybe there's a global variable that can be removed, or many kind of maybe minor things, maybe major things.
The other thing that the Goda tool is really useful for, I've found, is trying to sort of code bloat, which we haven't really talked about, is code bloat in your own code base. Like, so when your code base gets really big and you've done some changes and you've made some big migrations, but you've still got some old bits of code, and just trying to make sense of this tangle of dependencies, that you end up with something. If you have more or less a monorepo, then you can have a very tangled set of dependencies, and it's really quite hard to make sense of them somehow and to try and work out, okay, we want to factor these things out into their own thing, but you don't know where everything's coming into it, what's coming out of it. And I found that incredibly helpful when I was making some changes, particularly to my previous job at Influx Data, trying to do some big code changes. And it was quite hard to work out the dependency relationship. Of course, Go is fantastic because of a great rule that it has. You can have no cyclic dependencies.
Mm-hmm.
That is amazing, actually. With that rule, just in itself has contributed hugely, I believe, to the maintainability of larger Go code bases, because without it, you tend to get in this situation where something at the very top, very bottom of the dependency tree tends to point to something quite near the top. And then you have this big ball of mud, which you know, it's like a Gordian knot and you can't cut it, right?
Yeah, so for people that don't know, this is where, like, you'll have, say, 3 packages. A imports B, B imports C, that would be fine. But it's when then C imports A, and you get this kind of strange circle, right? Is that right?
Yeah, that's it. And also, like, it's a really good rule, but it was also really frustrating at times, because there are times you're like, oh, damn, we need to import this from here and we can't, right? Because it says cyclic dependency. So then you're like, then you have to break your dependencies, and often you have to split up a package, but it's not clear how you can split up the packages. It's actually quite a hard problem, but you're quite often forced to make this decision earlier than you would in some other languages, I think.
Yeah. And that's the thing. It's like, take on the pain early. A stitch in time saves 9, which means if you can stitch with 1, do it early, little bit of pain, saves that, because it grows and it becomes much more painful later. I've had the same thing too. And one of my approaches is actually just to keep everything in one package for as long as I can. As long as I can get away with it. I'm not joking. That genuinely works too. Like, because of that, yeah. Like, I quite like it when the structure emerges rather than is kind of imagined, because sometimes it's obvious, and sometimes I've got like dependencies that are like, I've got something that I want. I know it's going to be a package. I know it's going to be useful in multiple places. But I'm often surprised as well, as the application is being built, which bits kind of present. I certainly don't follow like just a standard structure that I know some people do.
I agree with that. Yeah, definitely.
So with binary bloat then, like you said, 16K used to be a kind of big program. And I remember, you know, a floppy disk was 1.44 megabytes that you could fit on that. If you take a photo now and share it, like, that's about 8 floppy disks or something at least. You wouldn't tolerate that if you're like, oh, you've got to check out this photo. Here's a little stack of floppies.
Those were big floppy disks as well, right? Started off at like 200K if you were lucky.
Yeah, when they used to be actually floppy.
Yeah, not to mention tapes.
Yeah. Oh no, honestly, I love that early tech. I really miss it when tech was rubbish. It was so cool. Like, I had a Spectrum with the tape cassette thing when I was a kid. So literally, and people won't believe this, but in order to load a program, I don't even know if they know what a cassette tape is either. So it's something that you sometimes see on retro t-shirts. One of those. Literally, then it was the sound. It was encoded as sound. So it would play the sound off the tape, and that would, like how a modem works, really. And then it would read the data, load the program, often with mistakes. So you'd need to do it a couple of times to get it right.
I think you now need to explain the modem as well.
Yeah, this is it. No, it's all changed so much. And by the way, I started young. I'm not old. Just want to make that clear. But why do we care about binaries now? Because we can get away with great big binaries, can't we? And what's the big deal? They upload in no time. They move around the web pretty quickly. Do we care about big binaries?
I think mostly we don't. Like, if we did, we already would have done something significant about it. But there are definitely cases where we do care.
I do get shocked by the size of binaries sometimes. I look at it, it's like, yeah. I'm expecting 5 megabytes or something. It's 120 megabytes. Wow, that's ridiculous.
And is that usually because you've imported something in your own program, or you just talking about anyone's programs?
I guess I'm just talking about building a binary and having a look. It's not me importing something particularly. But yeah, binaries are very big. I mean, I care more about binaries on small devices. Mm-hmm. If I'm running something on a Raspberry Pi, or actually even on a Raspberry Pi, you've pretty usually got quite a lot of SD card space. It probably doesn't matter either. But on smaller devices than that, then it really becomes an issue.
How many floppy drives can you attach to a Raspberry Pi?
How many floppy drives have you got?
Not enough.
Clearly.
None at the moment. Actually, I do have one because I've decided I'm going to buy all my old computers that I used to have. So I got a Spectrum already. It's arrived. I've ordered an Amiga 500 and I'm bidding on one on eBay, an Amiga 1200. These were my early computers that I kind of grew up with. So I will have some floppy drives.
That's a good idea.
Yeah. I'm just going to put them on the wall. Plug them in, but just have them on the wall.
I should get an Egon Archimedes again. That was my first ever computer that I owned.
Did you? That is cool.
At university, that was, yeah.
Yeah. We had those at school.
I started on a 286, so a bit later than you.
Yeah. What are you trying to say?
I started later.
Well done, you did a fine job.
This episode is brought to you by Chronosphere. Scaling cloud native is complicated, and Chronosphere helps teams take control of observability, tame rampant data growth, reduce cloud native complexity, and increase the confidence of the business. And I'm here with Martin Mao, co-founder and CEO of Chronosphere. Martin, if teams are bringing in more data, how do you help discern between signal and noise?
The two ways to look at solving those problems, one of which is we give tooling, but the higher level thought here is that for every piece of data that you're emitting, what is the value of that data? Do you treat every piece of data equally? You can imagine your development environment and your production environment, the data being produced out of the two of those, maybe one is a lot more valuable. So the higher level concept, and again, we give you tooling for it, but the higher level concept is that, you should be able to value the data at different rates and sort of attribute resources and costs to them in different ways as well. That's probably a way to solve the cost efficiency problem, a lot more than just asking for a discount from a vendor. And then on the second one, it's more the industry is pushing you to produce more data because that's how they make more money essentially. And we've lost sight of what are we really using these systems for? Nobody talks about how effective these systems are anymore. Everybody only talks about, what data types are you producing? Can your product handle logs, metrics, and traces? And the focus is almost on the wrong area of it.
All right, the next step is to head to chronosphere.io to explore the platform and get a demo again. Chronosphere.io.
Okay, so small devices, and this is kind of where TinyGo comes in, because this was the problem that TinyGo is trying to address, is that so that you can still use what is essentially like the standard library, but it's much smaller. It's deliberately designed to be cut down and simpler, isn't it?
Yeah. I love TinyGo. I use TinyGo a bit gratuitously. A friend said, I want to build a doorbell with like not tubes. What do you call them? Maybe call them tubes. With knockers dinging them and stuff.
Let's stick with tubes.
So I built him the software. He built the hardware, like he put the actual thing together with the relays and that, but he never actually got the tubes working. So I built this software, and it's great because you got this tiny little microprocessor, like, you know, maybe it was 16-bit, maybe 8-bit, I can't remember, pretty small with like 1K, 2K of RAM or something. And you could build this Go program, which you can use Go routines and everything, right? So I just had this like separate Go routine, which would be responsible for going through the tune, and then another one which was listening to interrupts, where you would, you would press the bells and it would interrupt that other Go routine. It was really nice way to structure it. Which you couldn't have done that if you were writing in C, and it was great, and it all fitted. Like, it was great. It turned the LEDs on in the end. It didn't ding the bells, but you could pretend.
Yeah, you could have a butler hire somebody to. When the lights come on, they hit the tubes.
At the same time, that would totally work.
If you could. Yeah, eventually work the way up to that. That sounds cool. I love that. And Egon, in the GopherCon EU in Berlin recently, you were hacking with TinyGo, weren't you?
Oh, yeah. I did some MIDI controller thingy.
Yeah, so he was playing music on he had these buttons attached to this little breadboard, and then wrote the code to translate that into MIDI instructions for some music software.
Yeah, it worked pretty well, and it was really nice.
Yeah, I liked it.
I did get some embedded device noise on it, so like some of the buttons didn't work as supposed to, but it still did things, I guess.
Yeah, it was like going doing, 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 which I think is good.
Yeah,
it's not as good as Roger on the fiddle.
There's lots of noise on that, I'm afraid. It was actually great using Go with TinyGo because you could have this debouncing code, totally didn't care about any of the other code. It would just sleep for a bit, wait for the debounce, and that was independent of all the other logic waiting for buttons and stuff. So
what was that doing then? The debounce, literally stopping if you got noise coming through from buttons or something?
Yeah, well, so if you press a button, then it's not a clean thing that you have pressed this button. There's usually, it makes contact and then bounces and comes down again and bounces and comes down and eventually ends up either down or up, right? But you don't know when that initial contact is made, which way it's gonna end up. So you have to you don't want it to go like that.
Yeah, you stress the butler out.
Yeah, you don't want to do that.
I did have debounce code, but something was wrong.
Well, that's funny because debounce, I've used that in the front end of web development, which is literally the same thing, which is if you click too many times or sometimes on hover, like, because you can, if you're just teetering on the edge, on the precipice of the pixel, you can end up with this horrible flicker. In your case, Roger, that is literally a bounce that you're talking about.
It is absolutely literally a bounce, yeah. It was quite interesting to write. And you could just write, so nice writing it in Go, honestly. Can't get over how nice it was. You even have like interfaces. They're quite clever about interfaces in TinyGo, actually, because they basically expand all the code out. They're really clever about some of the optimizations for space in TinyGo.
Yeah. Do you think people should, as an experiment, like use TinyGo and try and actually experiment with that, and also like run something on a tiny device just to sort of understand what's going on? Or is this, again, are we just at the point, most people, where we can just deal with the big binary?
I think it's well worth experimenting with it and having a go, see what it takes to run in 1K of RAM or whatever, because binaries are still quite big, but you can still have like 128, 256K of binary, but you're not going to be importing gRPC. The other place that binary bloat really matters is on the web, right? You can compile Go to WASM, but if you're downloading a 100 megabyte WASM file to your browser, that's not going to go so well. That's actually, I think, I haven't used it in this, but another use case for TinyGo is to target WASM and have a relatively small binary that gets downloaded to the browser.
Yeah, I've seen that. I've never done it myself, but I saw a talk, which I'll try and dig out and put in the show notes, of somebody that basically did that. They wrote something just in Go and showed you how long it took to actually run. And then, because it has to download into the browser. And then they did it in TinyGo, and it was obviously much snappier. I think there's an interesting future there with WASM, and I think therefore TinyGo probably does play a big part in that for Go people. I know that Ron Evans, one of the main contributors and I think the founder of TinyGo, he very much advocates for more people looking at TinyGo and using it and contributing. So he's very keen to get people on board with it as well.
Yeah, it's really cool. An interesting observation is that in the smaller Go programs, one of the main contributors to binary bloat is the FMT package, the FMT package, because that actually is quite big and so many things have it as a dependency.
Yeah, and it feels like something that's just baked in to the standard library and therefore is just around and you can just always use it. But if you think about all the things, when you use the verbs, like all the different things you can do, the reflection and everything, you can see why it ended up having lots of dependencies.
I mean, it hasn't itself got lots of dependencies, but it is itself quite a large amount of code, does a lot of reflection code. It's quite a lot of code.
I think one of the major contributors to FMT package is actually Unicode tables. Because it needs to handle many of those cases. And I think those tables, I might be wrong, but like a few hundred kilobytes or something already.
I don't know. Maybe white space. I'm not sure.
What do you mean white space? Surely it's not it's not padded out, is it?
I mean, it's 3,500 lines of code.
Oh, I could have done a quiz, Roger. You'd have got Egon back.
I mean, maybe scanf? I don't know. I'm not sure that FMT itself needs those Unicode tables. Maybe it does.
Maybe it has changed. But
yeah, I don't know.
Quickly looking at the code.
I remember optimizing those at some point. Trying to optimize them.
When I was doing some of this stuff, I was like, I just want a version of FMT that only has like the very basic verbs like %s, %d, doesn't even do widths, and you'd be fine in most cases.
Tiny FMT.
Tiny FMT, absolutely.
You could make that, Rog.
You can't replace standard library packages there.
Well, you probably can do anything you like if you have some kind of pre-processing thing going on. I'd actually genuinely like if it scanned to see which verbs you used and then built a FMT package that just had that. I don't know. It's maybe going too far.
I mean, that's kind of almost what Rust does, actually.
Is it?
Well, because in Rust, the formatting stuff is macro processing. So it kind of expands out at compile time.
Ah, yeah. That's cool.
That's why the compiler is so slow.
That's it. It's the trade-off you've got to make, isn't it? That's the thing about, I think, Go. Like, I'm always quite pleased with the trade-offs that they end up making. Like, I understand, and then someone will hit an edge case and they're really frustrated by it because it's not performing for them. But by and large, I think they are pretty pleased with where they usually land.
Yeah, me too. And it does seem to be. It is maintainable for large projects, but there is that kind of inherent complexity that you tend to accumulate when your project gets larger and larger. There's some threshold at which you kind of seem to cross, at which people stop understanding the code base. And that, I think, for me, that's really when code bloat, as I care about it, really kicks in. It's that people are making changes, they don't understand the code base, therefore they tend to reinvent the wheel or just write much more code to jam their feature into the code base, rather than seeing, oh, well, actually, we could just change this little package over here to add this feature and not add these 100,000 lines of code over here. And then you've added those 100,000 lines of code and it's even worse, right? For me, I think code bloat is quite strongly linked with technical debt.
Yeah, I think whenever you end up with bits of the system that you just don't touch, like, no, don't go and touch this, like, be scared of this. I think I've had that situation before. And even in projects where I've been the only one working on it, I just managed to get something right and I don't have the context and it's messy. I never cleaned it up. And then I just don't want to even touch it. And with Go, I find that I do less of that, particularly because testing is such a big kind of first-class concern in Go. And I tend to write TDD. So I will, at the end of writing and solving a problem, I can just go back and just very boldly hack away at it, change it, make big changes with the confidence that as long as the tests are passing, then all the promises I've made are still true.
That's great until you find that all the tests that you've written are using mocking and that you're changing some of the things that they depend on. And so all your tests are now invalid, right? Because this can be very hard.
Yeah, I think strategies like when you keep the interface near where you're going to use it, like that as a rule, I quite like. So some packages they'll expose interfaces. And I like the idea, like if I'm going to use like the SendGrid API, if I have a sender interface that just has the single method that I'm going to use in there, this to me, it's not really solving anything to do with code bloat, but I'm really explaining there that this is what I care about, this piece. And then if there's any mocking or anything like that, then it's much smaller. But yeah, I tend not to do much mocking. I tend to do a lot more integration testing.
Me too. And I think there's a good reason for that, because if you have integration tests and then you refactor the insides to maybe use something with less dependencies or something with a different kind of API, then your tests are still valid, right?
Yeah.
But if you rely entirely on substituting in something, the thing that's underneath, then you can't change the tests you can't change those dependencies because your tests are now invalid.
Yeah.
This is a big problem with larger code bases and being able to refactor so that you are changing your dependency network, for example.
So a question, what's your definition on technical debt? I've seen it used in many different ways, and I wonder what's your definition?
Mine or Matt's?
Both, I guess, if it's different.
It might be different. Well, just off the top of my head, I'd say it's something that I should have done now, but I'm not going to. You see, I tend to avoid it kind of quite rigorously wherever I can. So I'll go to great lengths to usually by shrinking scope, but I'll try and not do as much, and then I can do it well. But that's a very vague answer. I don't know if that resonated with you, Roger.
I mean, for me, technical debt is something that is like a cost that I'm unwilling to pay, or I was unwilling to pay in the past. Because you've always got to prioritize. You've always got to triage and do some things first and other things later. So technical debt is the things you left for later, right? You can pay that off early, or you quite often it's like, well, the other things are still more important, so we'll leave that. Or this is really too big. This is actually we're going to have to take an entire year out with our whole team in order to address this serious problem in our code base. And that will take us out of the market. We're not going to do that. It will mean we can't ship any features. So, this is a debt that you're not going to pay off, and you probably will never pay off. And that's the death, I think, of most projects.
It's like a mortgage. Mortgage, actually, the word it's like death loan. The mort in mortgage comes from death.
Oh.
Yeah, really. Because that was the idea. It was you just have this loan for your whole life. Sounds grim, doesn't it?
I never knew that.
At some point, I was thinking about technical debt, like trying to give it a rigorous answer, like what is it? So what I ended up is that, let's say you put there's some effort that you put into maintaining a code base. Like it doesn't need to be maintaining, but maybe there are other aspects. And then there's the ideal state of how much effort you need to put into the code base to maintain it, right? So the difference between those ideal state and your current state is going to be the technical debt, right?
Sounds reasonable.
Yeah, but there's one funny thing there. Let's say there's an innovation in the technology, right? Let's say when React came up, right? The ideal maintainability or the effort to maintain got lower, which means that your technical debt goes high up if there's an innovation. So
that's interesting. And does that mean that when you start a project and it's not by any means finished, that counts as technical debt because you just haven't finished that project that you've just started?
Yeah, I guess. Let's say you have a security debt. You haven't done a proper security audit, right? There are other aspects you can measure. And if you look at maintainability only, then an unfinished project isn't necessarily in debt because of its being unfinished, right? So the ideal state in terms of maintainability.
Yeah, so that is interesting. So in that case, because this is the other thing, if you have what you perceive to be a technical debt and you acknowledge it and you decide for priority reasons, we're going to leave it. And then later you find out we actually didn't need that. We never need it.
Yeah.
Then I guess that just pays off. It just kind of gets written off, the debt. Yeah. And so I think one of the other principles is like designing things so that you can change them, designing things for that flexibility in the future. I think is quite an interesting idea that I don't, when you think, I saw it on Twitter, somebody said, like architects. Architects are there, and it sounds great because it's like designing these systems, and they are laying these foundations and telling you where all the important pieces are going to be. And then someone said, if you called those people like technical, I forget the term they used. It was something like early decision, like unchangeable decision person. Like suddenly this sound really unreasonable, and that you wouldn't want that. So having like flexibility in the architecture and, being happy to change things and evolve things. I think acknowledging that we don't know stuff, we don't really know anything at the beginning, especially, and we'll learn it as we go.
That said, I think it really helps to do a lot of thinking through. You can actually design stuff. It might not be set in stone, but I do think that you can eliminate a lot of bad code paths or bad futures by just thinking them through to start with and thinking, well, if we went that direction, where would we end up? Like, that's a bad place to go. So I think a lot of people are like, we shouldn't do any design up front. I really don't agree with that approach at all. If you look at Go, for example, they designed a lot. They wrote the spec before they did the implementation.
Yeah.
I think there was one quote that when you're designing things, add flexibility into the places where you are most uncertain.
Yep, that's a really good point.
Yeah, that's true.
That sort of leads through to like one of the things where I think is sort of key to avoiding code bloat is just designing the right abstractions. If you get the abstractions right up front, there's this kind of feeling when you're wrestling with the wrong abstraction. You just feel like the code is piling up. You're just writing all this code, and because you've got the wrong abstraction, because you're doing things the wrong way, if you get it right, you sort of maybe you change your abstraction and start to do things differently, and suddenly all that you can like, oh gosh, I can delete that entire package. I can delete the entire directory. I can delete hundreds of thousands of line codes sometimes because you've changed the way it's working, and very subtle in what was initially maybe a not very obvious way.
I remember a talk about designing things for deletability so that it's easy to delete features rather than to extend, because if it's easy to delete, then it's probably easy to replace.
Yep.
Yeah, I like that point, actually. On the abstraction thing, like I talk a lot about kind of avoid doing the abstractions too early. Do a few examples first and see. It'll depend on the project or the problem. But actually, the real value is in these abstractions. Like that is really probably one of the most valuable things we can do, I think, to your point, Roger, is get an abstraction right like that. If you think about a lot of the big innovations that you see, like often it's an abstraction and it's the right one, and somehow they get it right. So that's the other thing, like it is very important, and practicing designing abstractions and honestly getting it wrong, like practicing and making those mistakes and living with the pain, and then you learn from that. And I think there is an element of it takes a lot of experience. Like I don't think any of these general rules apply, in every case.
If anyone wants a good exercise for practicing abstractions, people I mentor, I usually give this exercise is you need to write temperature conversion code. But now you need to write it in 20 different ways. And they have to be conceptually different, like design-wise, and like the different properties that they optimize for, right? For safety, for flexibility, for ease of maintainability, for prototyping, and all these aspects. And it kind of, like the first 5 may become easy, and then it starts to like become more and more difficult every single step of the way. But it makes you think of these different ways how you can implement things. So
that'd be a good talk.
That sounds like an interesting exercise, yeah.
Yeah, I'd like to see you do that in a talk.
Then he would ruin all the future things for his mentors to learn.
True.
Oh no, I can pick any different problem.
Yeah, the temperature thing reminds me, in my school, I was the first year to do IT as a GCSE. But the school just wasn't ready for it. No one really had computers. They were teaching how to do spreadsheets and word processing and things. But I was into computers from a very young age, so I really loved them. And one of the questions is, of these devices, is it an input device, a storage device, or an output device? Monitor. It's my turn to do a quiz. Roger, monitor, is that an input, output, or a storage device?
Input and output.
You can only pick one, Roger. Otherwise, you get no.
I can only pick one. Oh, okay.
Oh, mate, this is feel my pain.
Oh no. Oh yeah.
Well, worse was hard drive. Hard drive. It's like, how are you getting things on and off if it's not also input and output? I left those notes in the side on the exam, of course.
Of course you did.
Yeah, pedantic. But the last question was, they just said, design or explain how you would regulate the temperature in a swimming pool. And I wrote the basic code, because I used to write BASIC at home. So I wrote this little BASIC program that did that. And I don't know, it was just like, we didn't learn any of that at school. So of course, they were surprised, to say the least, but did all right.
This episode is brought to you by Honeycomb. Find your most perplexing application issues. Honeycomb is a fast analysis tool that reveals the truth about every aspect of your application in production. Find out how users experience your code in complex and unpredictable environments. Find patterns and outliers across billions of rows of data and definitively solve your problems. And we use Honeycomb here at Changelog. That's why we welcome the opportunity to add them as one of our infrastructure partners. In particular, we use Honeycomb to track down CDN issues recently, which we talked about at length on the Kaizen edition of the Ship It podcast. So check that out. Here's the thing. Teams who don't use Honeycomb are forced to find the needle in the haystack. They scroll through endless dashboards playing whack-a-mole. They deal with alert floods, trying to guess which one matters. And they go from tool to tool to tool playing sleuth, trying to figure out how all the puzzle pieces fit together. It's this context switching and tool sprawl that are slowly killing teams' effectiveness and ultimately hindering their business. With Honeycomb, you get a fast, unified, and clear understanding of the one thing driving your business: production. With Honeycomb, you guess less and you know more. Join the swarm and try Honeycomb free today at honeycomb.io/changelog. Again, honeycomb.io/changelog.
Egon, you made a point earlier about features, because I think that is another way to avoid bloat. And like a feature, when you imagine it, say, in a website and it shows up, it just seems like a logical thing to have. But sometimes that feature adds quite a lot of complexity to the system.
Yeah.
And considering the actual cost, the engineering cost, the maintenance cost, really, of features, I think is something that gets overlooked a lot. And where I am at Grafana, because all the leadership were engineers, like that is understood from the beginning. Like it's implied, we are always thinking about that. I've worked in places that's perhaps more sales driven or product driven. And that is like a fight that you have to have. But it's such an important point, I think, for people, that the feature, like the cost, maintenance more than how long is it going to take to build it, even, because you're maintaining it for much longer, hopefully.
I think one of the issues with features is that they are really hard to remove afterwards.
Yeah, because people rely on them, of course.
Yeah, you basically can't remove a feature when you've added it. The other thing is that interaction between features, that also leads to code bloat, because these things are maybe non-orthogonal. You're changing this other thing in the code base, and that interacts with all these other features which have to be updated. And then there's the whole thing about, well, you're designing this feature to fit this use case, and you can narrowly fit it, or you can say, well, let's think a little bit wider here. Maybe if we make this a little bit more general, we can cover not just this use case, but also all these other potential use cases, and make like more of a very generally useful feature. Then somebody asks for a feature later and they say, oh, no, you don't need that feature because you can use this other feature that we already built. I have to say that's hugely satisfactory when that happens.
Yes.
It doesn't happen often.
That is also a thing I think people should always ask themselves when you're considering how to solve a problem. This is why I always like it whenever use cases come in, when they focus on the problem, It's very easy for people to write a ticket to say, oh, we need a button here that does this. This is what our customers ask for.
Use a story.
Yeah, really, we want to know what's the problem that they're trying to solve. And then take a step back and see, like you say, and it's like, I can think of so many examples of places where we've had that thought, we found the general one, and then it's just paid dividends again and again and again down the line.
Absolutely.
So yeah, I think that's great.
That whole take a step back thing is actually key throughout all of software engineering, I think. Don't just focus directly on what you're trying to solve. Think through the code and in the wider situation. When you're reviewing code, this code is addressing this particular problem, but maybe it doesn't need to be. If you take a step back and fix it more generally, maybe do a little bit more work now up front, but that might save you more bloat in the future.
Mm-hmm. Well, it's that time. It's that time that we always have a time on Go Time, and it's this time. It's Unpopular Opinions time. It's time also for the theme tune.
I actually think you should probably leave.
Roger, would you record a fiddle accompaniment to that so that we can play it next time on?
All right, done.
Oh, that's going to be great. Thank you. And we'll get your Tiny Go music machine as well, Egon, which I already have a recording of. Okay, so who's got an unpopular opinion for us today?
I think I already said it, but you should review every line. It's either direct or indirect of your dependencies with similar standards as your own code base.
See, I think that might be a good one for an unpopular one. I think that might be unpopular. So you're saying if before you import a package, read every line and
yes.
What about its dependencies?
Those as well, of course.
And presumably every time you update to a new version, right? You have to review all the changes too, right?
Yeah. I think people import packages assuming they are better than their code bases, right?
Yeah.
And if you have such really high standards for your own base, why wouldn't you have those as well for other code bases?
Yeah, isn't it about responsibility?
Yeah.
Sometimes there are packages out there and they maybe have a couple of stars. They're not really used by anybody. But there are clues, there are signals to look for packages that are sort of a bit meatier and a bit more stable. Is it our responsibility?
I have to say that I don't do that. What I do tend to do is when I look at a dependency, I look through the code and say, does this look like what I would expect to find in a package that is implementing that functionality? Does it generally look good, feel about right? Is this too big for what it should be? And I quite often say, no, let's not have this is horrible.
Yeah, does it have tests? That's a quick check.
To be honest, I struggle to understand my own code, let alone other code that I'm importing. So I couldn't understand the gRPC code, the HTTP2 code. Somebody's spent man centuries probably working on that code. And there's no way I could meaningfully review it, I don't think.
Man or woman years? Their years. That's the modern measure of time.
Sorry.
Yeah, that's all right.
Person years.
No, yeah. Go on, Egon. What do you reckon?
But yeah, I think it has many benefits if you do review them, even if you don't understand them, right? Because if you're reviewing other code, you might look at how they build things. Maybe you learn something new, right? Maybe you discover some bugs that need to be fixed because you have different expectations of the code base. Of course, when I say you review them with the same standard, you don't worry about the formatting details or they decided to use spaces instead of tabs. Fine, let them have
I do
those spaces.
No way can they use spaces. Just absolutely no out.
And also there have been many attacks against code injections and that you should be worried about, right? So
it's one of those that's hard to argue against once somebody said it. It's like if someone says you should have all this extra security, it's hard to say, no, we shouldn't.
Yeah.
But practically.
I think it's easy to argue against because I don't think it's reasonable. I don't think it's possible for most people. I think that we should have better supply, better dependency chain assurances, honestly.
But until then.
Than we do.
I do think there is a case where you don't need to review them if you're actually paying someone else to maintain that code base. Like then you're like intentionally offsetting your own responsibility to somebody else. Like I do consider like every dependency as your own responsibility to maintain and to fix things when things go critically wrong. Right?
I mean, with that rule in place, you certainly be incentivized quite strongly not to include many dependencies. So it has that effect too.
Of course, yes. Like, do you really want to review gRPC?
I do now. I'm going to print it out and take it to bed.
Maybe you can make a bed out of it already.
Yeah. Nice. Okay, Roger, have you got an unpopular opinion for us?
Yeah.
My unpopular opinion is that I think that often just working on a laptop with just a small screen, not on my big desk with multiple monitors, mouse, etc., just my laptop with my little screen and just a keyboard, maybe just on a sofa or something, is actually more productive than working on my big desk with multiple monitors and all the stuff. It seems that way to me.
Yeah, so is this about like there's no distractions and you're just like in that world?
I think it might be. I don't really understand it, to be honest, because it should be that I've got all these, I can see all the things, I can do all the things. I've got the nice, rising desk, all the stuff that's absolutely optimized for me. And then I can sit on the sofa with my laptop and suddenly the code starts to flow.
What do you think of that, Egon?
I do think it's nice. Like I occasionally go to coffee shops to program there, and like it does give you a bit more focus. So
yeah, I also wonder, Rog, if it's because most of your time has been spent there, rather than like if you think about in the past, you didn't have all this tech and these monitors and a desk that moved up and down.
In the past, I didn't have a laptop. That's where laptops are a new thing, really.
Just have to have your computer, have your monitor on your lap if you want to do that.
It was a bit big and heavy, that big 17-inch thing.
By the way, instead of those desks that go up and down, it's a bit more expensive, but you can actually just have your entire floor move and same effect, have your desk fixed, and then you just move the floor.
It's funny because I got this rising desk, which technically has 4 saved positions in that. And I actually never use it anymore. I just stand. I started off and I'd stand and I'd sit. Now I might as well just got a desk of that height.
Oh, yeah.
I never sit down. Apart from when I'm on the sofa. Maybe that's the reason.
But why do you need 4? Because you've got standing, sitting. Is there one like when you're on your knees praying, like you're really hoping the code's going to work?
My theory is that it's for you and one other person.
Yeah, that's my theory too. But for comic effect, I pretended not to know
For
that.
comic effect? Oh,
that just doesn't always work. Thank you. Let me ask you this, Roger, as well. Are you a keyboard wizard type? Do you use Vim, Emacs, that kind of thing?
I am absolutely not. We might have got into this, actually, because a previous unpopular opinion of mine was that Acme is the best text editor. And Acme is a radically mouse-focused text editor. So I don't even touch type, actually. I never learned, and I never went back to properly learn.
How do you get the keys to happen? You blow on them, but you refuse to touch it.
Yeah, I just kind of, 2-finger, very slow. Look for the key.
I worked with a guy who typed with a single finger, and he was faster than me. And I've never seen anything like it since.
What?
I hadn't seen anything before. Haven't seen anything like it since.
Not even 2 hands?
Not even 2 hands. What? Single finger, 1 hand. It's just how he learned. And I've no idea why that happened.
I kind of 3 fingers, maybe 4, because 1 for the shift, little thing for the shift key.
Oh, I assumed it was 2 for someone else. Like 2 fingers for you to type, and then you've got 2 spare if you want to help out someone else's.
So I think the mouse is great. I don't like keyboard shortcuts in general. They get in my way.
Egon, what sort of editor are you into, mate?
Oh, I use 3 different ones.
Okay, thought it might.
So I use Sublime.
I thought it wouldn't be a simple answer. Something told me. Yeah. Sublime.
I use Sublime, VS Code, and Golang.
Oh, yeah.
So depending on what I'm doing. So and I guess I edit the commit messages in Vim because I haven't bothered to change the default editor.
Oh, fair enough. That's pretty cool. Yeah, I always wonder about these people that are amazing on the keyboards. It's like, I always look up to them, but maybe it is that they're rubbish with a mouse. Like, they just can't do it. And it could be that.
I actually quite like the touch point thing. So I don't use the touchpad. When I do use my laptop, I don't use the touchpad. I use this touch point thing, which is only on Lenovo's.
What is that?
It's just a little nipple that's in the middle, red thing, which is in the middle of the keyboard. And I think it works really well.
I do miss my touch point. So
Interesting.
Yeah, so it's like a little thing with a grip on it, isn't it? And it's essentially like a joystick.
Yes.
It's like a tiny joystick.
Yeah, a joystick, except it doesn't move. You just kind of push it. And it does lose its grip after a while, after like a year or so. You have to get another one.
Oh, mate.
A replacement thing with more friction.
Oh, you could moisturize your hands.
Yeah, it's really bad. If you're really sweaty, it can be a problem. It can.
Well, speaking of being really sweaty, my unpopular opinion, I've got one today. I don't understand shower gel. I don't know if you've seen it or you have it. It's like some kind of bath time slime, and it never smells great. And people have it. Sometimes I'll go to my brother's and I'll go in the shower, and he doesn't have any soap. He just has these bottles of shower gel, and it's sort of just slimy, and I don't know, never feel clean. I'm not happy with it. What's your stance on shower gel?
I tend to agree with you about shower gel because it just all drips away. It's like it doesn't. Whereas give me a bar of soap.
Yeah,
it's there, right?
You can really go to town.
Don't you use a sponge for it?
Oh, a sponge.
Sponge? No.
Like something fluffy?
Oh, that makes sense.
Yeah.
That does make sense, though.
I suppose that does make more sense. No.
Do you also feel the same about shampoo?
No, although I realise that is very similar. I don't have loads of hair.
I have to say that I have recently, in the last couple of years, changed to using bar soap for the shampoo. You can get these shampoo bar soaps, and that works really well. Mm-hmm. So you don't have that bottle which you have to throw away, so less plastic.
Nice.
It lasts for ages. Actually works really well.
Sold.
I totally recommend it.
I want everything in a bar. I want a bar of toothpaste now. You just rub the bar in. No, but like a shower gel, like in some places where the water's soft, it doesn't even all properly come off. So you end up being all slimy.
You are like putting it on during the shower and not afterwards, right?
To be fair, I've not read the label. I maybe use the error, but I just don't get it. I just don't like it. I like a nice rough bar of soap, something that's rugged and, you know what I mean? I'm not like one of those really manly people.
Like steel wool.
Steel wool. Oh, yes, please. I like a towel. I went to a hotel. It was a bit fancy. And the towels were all soft. And it's horrible. I want a rough towel. I want it like an elephant rubbing up against a tree, please.
Loofah.
Yeah. Well, I'm afraid that's all the time we have. But I learned a lot, mainly about bath things, but also about code bloat. So thanks very much to my guests, Roger Peppe. Always a pleasure, Roger. Hopefully you'll come back soon.
It was a pleasure.
Yeah, and Egon Elbre. Always
Yes, it's been
emotional.
Awesome.
Oh, yeah. Good. It's been great to have you. We'll see you next time.
All right, that is go time for this week. Thanks for listening. If you're new to the pod, subscribe now. Head to gotime.fm for all the ways. And hey, we've added chapters to all of our shows. If you don't see them in your podcast app, maybe you need a better one that supports this awesome feature. If your app does support chapters and you still don't see them, email editors@changelog.com or hit us up on the Twitters. We're at GoTimeFM. Thanks again to our partners at Fastly for CDNing for us, to Fly.io for hosting our app servers and database, to the mysterious Breakmaster Cylinder for the dope beats, and to you for being part of the GoTime community. We appreciate you. Next time on GoTime, Natalie and Angelica are talking Agile with Inbal Cohen. We'll have that one ready for you next week.